The James Webb Space Telescope looked deeper into space than any instrument before it, and what it discovered has left astronomers questioning the very foundations of our understanding. In this gentle exploration, we'll uncover why Webb's observations aren't just surprising, they're fundamentally terrifying to scientists who have spent their careers studying the universe. But before we begin, feel free to comment your time and location below. It's always amazing to see when and where we're all watching from as we contemplate these cosmic mysteries together. Also, the visuals are here for you, but feel free to close your eyes, breathe deep, and let your imagination float through the vast darkness of space. I would love and encourage you to watch until the end to discover these mind-bending revelations. But there's absolutely no problem if you doze off midway through. Let your thoughts drift across the cosmic web of discovery. Let's begin this journey into the terrifying beauty of what lies beyond. Picture yourself standing in your backyard on a clear night, gazing up at the stars. Those tiny points of light seem peaceful, eternal, unchanging. For thousands of years, humans looked at that same sky and believed they understood what they were seeing. We thought we knew how big the universe was, how old it was, and how it came to be. But the James Webb Space Telescope has shattered those comfortable assumptions in ways that should make us all pause and wonder what else we might be wrong about. When Webb first opened its golden eye to the cosmos, scientists expected to see what they had predicted. They expected to find a young universe slowly building its first structures, with small, simple galaxies gradually growing larger over billions of years. They expected to find a cosmos that followed the rules, that made sense according to our carefully constructed theories. Instead, Webb found something that has kept astronomers awake at night, staring at their data in disbelief. The telescope looked back over 13 billion years into the past, to a time when the universe was supposed to be a cosmic infant. What it saw there defies explanation. Where there should have been darkness and simplicity, Webb found blazing light and impossible complexity. Where there should have been tiny, primitive structures just beginning to form, it discovered massive, fully formed galaxies that shouldn't exist. Think about what this means for a moment. Imagine if an archaeologist digging through ancient ruins expected to find simple stone tools from early humans, but instead uncovered a modern smartphone. That's the level of impossibility we're dealing with here. The universe appears to have been far more advanced, far earlier than our physics says is possible. Webb detected galaxies that formed when the cosmos was only a few 100 million years old. That might sound like a long time, but in cosmic terms, it's like finding a redwood forest that sprouted yesterday. These galaxies contain billions of stars, massive black holes, and complex structures that should have taken many billions of years to develop. Yet there they are, shining brilliantly in the ancient darkness, mocking our understanding of how the universe works. But the terrifying discoveries don't stop there. Webb found something even more disturbing when it looked at the sheer number of galaxies in what we thought was empty space. Previous telescopes had counted the cosmic population and declared the census complete. Webb looked at those same regions and found 10 times more galaxies than anyone predicted. 10 times more. That's not a small error in measurement. That's a fundamental misunderstanding of reality itself. Imagine if you thought your neighborhood had 100 houses. but then someone with better vision looked around and counted 1,000, you'd start questioning everything you thought you knew about where you lived. That's exactly what's happening to cosmology right now. The universe is far more crowded, far more active, and far more mysterious than we ever imagined. These discoveries create what scientists call the too much, too early problem. The early universe was producing too much light, forming too many stars, and building too many galaxies in too little time. It's like watching a construction crew build a skyscraper in a day when you know it should take years. The math simply doesn't work with our current understanding of physics. Consider the implications. If our most basic assumptions about cosmic evolution are wrong, what else might we have missed? If galaxies can form impossibly quickly, if the universe can be impossibly crowded, then perhaps the very nature of space and time operates differently than we thought. Perhaps there are forces at work that we haven't discovered, laws of physics we haven't written, possibilities we haven't imagined. Webb also discovered supermassive black holes lurking at the centers of these ancient galaxies. These cosmic monsters weigh millions or billions of times more than our Sun, and they're actively feeding on surrounding matter, blazing with energy that outshines entire galaxies. But here's the terrifying part. These black holes exist when the universe was supposed to be too young to create them. Black holes form when massive stars die and collapse. But massive stars need time to live their lives and reach the end. Even the most massive stars burn for millions of years before they explode. Then the black holes they leave behind need more time to grow by consuming surrounding matter. The process should take billions of years to create the monsters Webb observed, yet there they are, fully formed and feeding, in a cosmos that's only a few 100 million years old. It's like finding a 1,000-year-old oak tree in a forest that was planted last week. The timeline doesn't make sense. The physics doesn't work. And scientists are starting to wonder if everything they thought they knew about how the universe develops might be fundamentally wrong. Some researchers have proposed that these early galaxies and black holes formed through processes we don't understand. Perhaps dark matter behaves differently than we thought. Perhaps the early universe was denser and more efficient at building structures. Perhaps there are mechanisms of cosmic evolution that we haven't discovered yet. But these are guesses, not explanations. The observations are real. The theories are scrambling to catch up. The most unsettling aspect of Webb's discoveries isn't just that they contradict our predictions. It's that they suggest the universe might be operating according to rules we don't comprehend. For centuries, science has progressed by observing nature, forming theories to explain what we see, and testing those theories with more observations. This process has been incredibly successful, giving us everything from electricity to space travel to the internet. But Webb's observations suggest there might be limits to this approach. Perhaps the universe contains phenomena that are so foreign to our experience, so different from what we can study in laboratories, that our current methods of understanding simply aren't adequate. Perhaps we're like ants trying to understand nuclear physics. We can observe the effects, but the underlying reality might be forever beyond our grasp. This creates an existential crisis for cosmology. If our basic understanding of how the universe works is wrong, then what can we trust? If galaxies can form impossibly quickly and black holes can grow impossibly large, then perhaps space and time themselves work differently than we thought. Perhaps causality operates according to principles we haven't discovered. Perhaps reality itself is stranger than we can imagine. Webb has also revealed that the cosmic web, the largest structure in the universe, might be far more complex than we realized. This web consists of dark matter filaments connecting galaxy clusters across hundreds of millions of light years. Previous observations suggested this structure formed gradually over billions of years. But Webb's data indicates that massive structures existed much earlier than they should have. The telescope detected galaxy clusters and superclusters that formed when the universe was young. These structures contain thousands of galaxies held together by gravity, spanning distances that light takes millions of years to cross. Building such enormous structures should require vast amounts of time for gravity to pull matter together across cosmic distances. Yet Webb found them already assembled in the early universe, as if someone had fast-forwarded cosmic evolution. This discovery forces us to confront uncomfortable questions about the nature of time itself. Perhaps time doesn't flow at a constant rate throughout the universe. Perhaps the early cosmos experienced time differently than we do today. Perhaps the expansion of space affects not just distances, but the very rate at which events unfold. These possibilities venture into territory where science meets philosophy, where our understanding of reality itself comes into question. As we drift deeper into these cosmic mysteries, remember that you're witnessing a pivotal moment in human understanding. We're living through a time when our most fundamental assumptions about existence are being challenged by direct observation. The universe is revealing itself to be stranger, more complex, and more mysterious than we ever dared imagine. But perhaps the most terrifying discovery of all is still to come. Webb's observations suggest that what we can see might be only a tiny fraction of what actually exists. The observable universe, that sphere of space from which light has had time to reach us, might contain trillions of galaxies instead of the hundreds of billions we previously estimated. And beyond that observable boundary lies the vast unknown, stretching possibly to infinity, filled with structures and phenomena we may never be able to study. The implications ripple through everything we thought we understood about existence itself. If Webb can detect galaxies that shouldn't exist, formed through processes we can't explain, then what does this say about the reliability of scientific knowledge? We've built our understanding of the cosmos on careful observations and mathematical models, layer upon layer of theory tested against reality. But Webb's discoveries suggest that reality might be fundamentally different from what our theories predict. Think about how we measure cosmic distances and ages. We use the light from distant objects as cosmic archaeologists, reading the history written in starlight that has traveled for billions of years to reach us. The farther we look, the further back in time we see. This method has been the backbone of cosmology for decades, but Webb's observations suggest that the story this light tells might be incomplete or even misleading. When Webb detected fully formed galaxies existing just a few 100 million years after the Big Bang, it wasn't just finding objects that were surprisingly old. It was discovering that the universe's timeline might be fundamentally wrong. These galaxies show signs of stellar populations that should have taken billions of years to develop. They contain elements forged in multiple generations of stars, elements that require time to be created, dispersed, and incorporated into new stellar systems. The chemical signatures Webb detected in these ancient galaxies tell a story of rapid cosmic evolution that defies our understanding of stellar life cycles. Heavy elements like carbon, oxygen, and iron don't appear instantly. They must be forged in the nuclear furnaces of massive stars, then scattered through space when those stars explode as supernovas. This process should unfold over many stellar generations, each one enriching the cosmos with heavier elements than the last. Yet Webb found galaxies rich in these heavy elements existing when the universe was supposedly too young for this enrichment process to have occurred. It's like finding a library filled with volumes of human history in a civilization that was supposedly founded yesterday. The book shouldn't exist because there hasn't been time to live the experiences they describe. This discovery forces us to question whether time itself behaves the way we think it does on cosmic scales. Perhaps the early universe operated under different physical laws than those we observe today. Perhaps the rate of stellar evolution was dramatically different in the dense, energetic environment of the young cosmos. Perhaps there are mechanisms of cosmic development that we haven't yet discovered or imagined. Webb also revealed that these impossible galaxies aren't scattered randomly throughout the early universe. They appear to be connected by vast structures, primitive versions of the cosmic web that shouldn't have had time to form. The telescope detected filaments of matter stretching across millions of light years, connecting galaxy clusters that existed when the cosmos was supposedly still a chaotic soup of particles and energy. The formation of such large-scale structures requires dark matter to clump together under its own gravity, creating scaffolding that attracts ordinary matter. This process should be gradual, taking billions of years for gravity to organize matter across such vast distances. Yet Webb found evidence of organized cosmic architecture existing almost immediately after the Big Bang, as if the universe had somehow skipped its childhood and jumped straight into adolescence. These observations challenge our understanding of dark matter itself. This mysterious substance makes up roughly 85% of all matter in the universe, yet we can only detect it through its gravitational effects. We've never directly observed a dark matter particle, never captured one in our laboratories, never fully understood what it actually is. Our theories about dark matter are based on how it appears to behave on large scales, pulling galaxies together and shaping cosmic structure. But Webb's discoveries suggest that dark matter might behave very differently than we thought, especially in the early universe. Perhaps it clumps together more efficiently under certain conditions. Perhaps it interacts with ordinary matter in ways we haven't detected. Perhaps there are different types of dark matter that operate according to different rules. These possibilities open up entirely new realms of physics that we're only beginning to explore. The telescope's infrared vision has also revealed that many of these early galaxies are shrouded in cosmic dust, making them invisible to previous observations. This dust absorbs and scatters visible light, hiding the galaxies behind veils of darkness. But infrared light can penetrate these dusty cocoons, revealing the stellar nurseries hidden within. Webb discovered that star formation in the early universe was far more vigorous than anyone predicted, with some galaxies producing stars at rates hundreds of times faster than anything we see today. This intense star formation creates its own set of impossibilities. Stars require gas to form, and that gas must be cold enough for gravity to compress it into stellar cores. But rapid star formation should heat the surrounding gas, preventing new stars from forming. It's a self-limiting process that should regulate itself. Yet Webb found galaxies that somehow overcame this limitation, continuing to form stars at breakneck speeds without running out of fuel or overheating their stellar nurseries. The energy output from these star-forming galaxies is staggering. Some of the objects Webb detected are producing light equivalent to trillions of suns, concentrated into regions smaller than our own galaxy. This level of energy production should have dramatic effects on the surrounding cosmic environment, heating gas across vast volumes of space and preventing nearby galaxies from forming. Yet Webb found these cosmic furnaces surrounded by other actively star-forming galaxies, as if the usual rules of cosmic feedback and regulation simply didn't apply. Perhaps most terrifying of all is what Webb's discoveries suggest about our place in the cosmic timeline. We've long assumed that we live in a universe that's roughly 14 billion years old, with most of its major structures forming over the past few billion years. This timeline places us in a relatively mature cosmos, one where the major phases of cosmic evolution are well underway but not yet complete. But if Webb's observations are correct, if massive structures and complex galaxies formed almost immediately after the Big Bang, then we might be living in a universe that's far older in terms of its development than we thought. Perhaps the major epoch of cosmic evolution happened in the first billion years, with everything since then being merely a long, slow decline toward cosmic senescence. Perhaps we're not witnesses to the universe's youth and middle age, but to its twilight years. This possibility reframes our entire understanding of cosmic evolution and our place within it. Instead of living in a dynamic, evolving universe full of potential for future development, we might inhabit a cosmos that has already passed through its most creative and energetic phase. The galaxies, stars, and structures we see around us might be ancient relics of a far more spectacular era, fading echoes of cosmic processes that we'll never witness firsthand. Webb's observations also raise disturbing questions about the nature of scientific observation itself. For centuries, we've relied on the assumption that looking deeper into space provides an accurate picture of cosmic history. We've trusted that the light reaching us from distant galaxies carries reliable information about the conditions that existed when that light was emitted. But what if this assumption is wrong? What if the very act of observing the universe through electromagnetic radiation provides an incomplete or distorted picture of reality? What if there are aspects of cosmic evolution that don't leave traces in the light we can detect? What if the universe operates according to principles that are fundamentally invisible to our current methods of observation? Webb's impossible discoveries suggest that our understanding of the cosmos might be built on foundations far less solid than we believed. As you contemplate these possibilities, remember that you're witnessing science at a crossroads. We're facing observations that challenge our most basic assumptions about how the universe works. The comfortable certainties that have guided cosmology for decades are crumbling in the face of Webb's revelations. We're entering an era where the cosmos appears stranger and more mysterious than we ever imagined, where our most sophisticated theories struggle to explain what we actually observe. The universe that Webb has revealed is not the orderly, predictable cosmos we thought we knew. It's a place where galaxies form impossibly quickly, where black holes grow to impossible sizes, where structures span impossible distances in impossible timeframes. It's a universe that seems to operate according to rules we don't understand, following patterns we can't predict, evolving in ways that contradict our deepest scientific intuitions. And perhaps most unsettling of all, Webb's discoveries suggest that this strange, impossible universe is the one we've been living in all along. The comfortable illusion of cosmic understanding has been shattered, revealing a reality far more complex and mysterious than we ever dared imagine. We stand at the threshold of a new era in astronomy, one where the questions vastly outnumber the answers, where every observation potentially overturns decades of careful theory, where the universe itself seems determined to remain forever beyond our complete comprehension. The implications of these discoveries extend far beyond academic curiosity. When Webb detected galaxies containing billions of stars in regions where only millions should exist, it wasn't just finding more objects than expected. It was revealing that the universe might operate according to principles that make our current understanding obsolete. These observations force us to confront the possibility that everything we thought we knew about cosmic evolution could be fundamentally wrong. Consider what happens when you build a theory based on incomplete information. For decades, astronomers constructed models of cosmic development using the limited data available from ground-based telescopes and early space observatories. They created elegant mathematical frameworks describing how matter clumps together under gravity, how stars form from collapsing gas clouds, how galaxies merge and evolve over billions of years. These theories seemed to work beautifully, explaining most observations and making successful predictions about what future telescopes might find. But Webb's infrared vision has revealed that these theories were built on a foundation of missing data. The telescope can see through cosmic dust that completely obscured entire populations of galaxies from previous observations. It can detect light that has been stretched by cosmic expansion into wavelengths invisible to human eyes and earlier instruments. What appeared to be empty space turns out to be teeming with galactic structures that were simply invisible until now. The sheer abundance of these hidden galaxies creates what scientists call an accounting problem. When you count all the matter that should exist in the universe based on Big Bang nucleosynthesis and cosmic microwave background observations, then compare it to what Webb actually detects, the numbers don't match. There appears to be far more organized matter in the form of stars and galaxies than our models predicted could exist by this point in cosmic history. This discrepancy suggests that either our understanding of the Big Bang is incomplete, or that matter organizes into structures far more efficiently than we thought possible. Both possibilities are deeply unsettling for cosmology. If the Big Bang models are wrong, then our entire framework for understanding cosmic origins needs to be rebuilt from the ground up. If matter can organize more efficiently than our physics predicts, then we're missing fundamental principles about how gravity, dark matter, and cosmic evolution actually work. Webb has also detected what astronomers are calling impossible chemical signatures in these early galaxies. The telescope's spectroscopic instruments can analyze the light from distant objects to determine what elements they contain. When scientists examined the spectra from galaxies that formed shortly after the Big Bang, they found evidence of heavy elements that shouldn't exist yet. These heavy elements can only be created inside stars through nuclear fusion, then dispersed into space when those stars die in supernova explosions. This process requires multiple generations of stellar evolution, with each generation creating heavier elements than the last. The presence of elements like carbon, oxygen and nitrogen in the earliest galaxies suggests that entire cycles of stellar birth and death had already occurred when the universe was supposedly too young for even the first stars to complete their life cycles. It's as if Webb found evidence of a mature ecosystem in what should have been a primordial environment. The chemical complexity it detected requires a history of cosmic processes that supposedly hadn't had time to unfold. Either these galaxies evolved far more rapidly than physics allows, or our understanding of stellar evolution and element formation is fundamentally flawed. The telescope has also revealed that many of these early galaxies contain supermassive black holes that are actively feeding on surrounding matter. These feeding black holes create some of the brightest objects in the universe, called quasars, which can outshine entire galaxies. The problem is that building a supermassive black hole should take billions of years, even under the most favorable conditions. Black holes grow by consuming matter, but there are strict limits to how quickly they can feed. When matter falls toward a black hole, it heats up and radiates energy. This radiation creates pressure that pushes against additional infalling matter, creating a natural speed limit for black hole growth. Even if a black hole started feeding immediately after the Big Bang and consumed matter at the maximum possible rate, it shouldn't be able to reach supermassive proportions for several billion years. Yet Webb found these cosmic monsters fully formed and actively feeding when the universe was less than 1 billion years old. Some of these black holes appear to weigh billions of times more than our Sun, far exceeding what the known physics of accretion allows. Their existence suggests either that black holes can grow through mechanisms we don't understand, or that they form through processes entirely different from what our theories predict. Perhaps most disturbing is what Webb's observations suggest about the nature of cosmic time itself. We've always assumed that time flows uniformly throughout the universe, that 1 billion years in the early cosmos equals 1 billion years today. But the rapid development Webb observed in early galaxies suggests that cosmic processes might have unfolded at dramatically different rates in the past. This possibility touches on some of the strangest aspects of Einstein's relativity. Time is not absolute, but depends on gravity and motion. In the dense, energetic environment of the early universe, with matter packed more tightly and moving at higher velocities, time itself might have flowed differently than it does today. What appears to us as impossibly rapid development might have unfolded over subjectively longer periods from the perspective of objects in that ancient cosmic environment. If this interpretation is correct, then our entire framework for understanding cosmic chronology needs revision. The 14 billion year age of the universe might be accurate from our current perspective, but the early universe might have experienced far more subjective time than we realize. This would allow for the complex development Webb observed without violating the laws of physics, but it would require us to completely reconceptualize how cosmic evolution unfolds. The implications extend to our understanding of cosmic structure formation. Webb detected vast cosmic web filaments connecting galaxy clusters across hundreds of millions of light years in the early universe. These structures represent the largest organized features in the cosmos, requiring gravity to pull matter together across immense distances. Building such structures should take many billions of years, yet Webb found them already in place when the universe was young. This suggests that either dark matter behaves very differently than we thought, or that there were initial conditions in the early universe that we haven't accounted for. Perhaps the cosmic web didn't form gradually through gravitational collapse, but emerged almost immediately after the Big Bang through processes we don't understand. Perhaps dark matter can organize itself through mechanisms that operate far more efficiently than ordinary gravitational attraction. These possibilities force us to confront how little we actually know about dark matter, despite its crucial role in cosmic structure formation. We've inferred its existence through gravitational effects, but we've never detected it directly or understood its fundamental properties. Webb's observations suggest that dark matter might be far more dynamic and influential than we realized, capable of rapidly organizing cosmic structure in ways that contradict our current models. The telescope has also revealed that star formation in the early universe proceeded at rates that should have been impossible to sustain. Some of the galaxies Webb detected were forming stars at rates hundreds of times faster than anything observed in the modern universe. This intense star formation requires vast quantities of cold gas, but the process of forming stars should heat the surrounding gas and shut down further star formation. Yet Webb found galaxies that somehow maintained these extreme star formation rates for extended periods, suggesting that they had access to continuous supplies of cold gas, or that the feedback mechanisms that regulate star formation worked differently in the past. Either possibility requires revising our understanding of how galaxies acquire fuel for star formation and how that fuel is processed into stellar populations. The energy output from these star-forming galaxies creates another layer of impossibility. The combined light from billions of rapidly forming stars should heat the surrounding intergalactic medium to temperatures that prevent nearby galaxies from forming. Yet Webb found clusters of these intensely star-forming galaxies in close proximity, suggesting that the usual environmental effects that regulate galaxy formation were somehow suppressed in the early universe. As we drift deeper into these cosmic revelations, consider what they mean for our place in the universe. We've long believed that we live in a cosmos that's still evolving, still building new structures, still in the process of reaching its full potential. But Webb's observations suggest that the universe might have reached its peak creativity and energy output in its first billion years, with everything since then representing a long, gradual decline toward cosmic senescence. This reframes our entire perspective on cosmic evolution and our significance within it. Instead of witnessing a universe in its prime, we might be observing the fading remnants of a far more spectacular cosmic epoch. The galaxies, stars, and structures around us might be ancient relics of processes that operated with an intensity and efficiency we'll never see again. The philosophical implications are staggering. If the universe's most creative period occurred billions of years before Earth even formed, then we emerged during cosmic twilight rather than cosmic dawn. We're not witnesses to the universe's youth and development, but to its old age and decline. The very fact that we exist to observe the cosmos might place us in a cosmic era where the most interesting and energetic processes are already ancient history. Webb's discoveries also raise profound questions about the limits of scientific knowledge itself. For centuries, we've operated under the assumption that careful observation and mathematical modeling can eventually explain any natural phenomenon. We've built layer upon layer of understanding, each new theory extending our comprehension further into the unknown. But Webb's impossible observations suggest that there might be aspects of cosmic reality that lie permanently beyond our ability to understand. Perhaps the universe operates according to principles so foreign to our experience that our minds simply cannot grasp them. Perhaps there are mechanisms of cosmic evolution that transcend the categories of thought and observation that define scientific inquiry. Perhaps we're fundamentally limited beings trying to understand an unlimited cosmos, like bacteria attempting to comprehend quantum mechanics. This possibility doesn't diminish the value of scientific investigation, but it does suggest humility about its ultimate scope. Webb has shown us that the universe is stranger than we imagined, but it has also revealed that our imagination itself might be the limiting factor. We can observe the impossible, document it, and catalogue it, but that doesn't mean we can truly comprehend it. As you contemplate these cosmic mysteries, remember that you're living through one of the most significant moments in the history of human understanding. Webb's observations represent a fundamental challenge to our conception of reality itself. We're not just discovering new objects or refining existing theories. We're confronting the possibility that our entire framework for understanding the cosmos is inadequate to explain what actually exists. The universe Webb has revealed is not the orderly, predictable place we thought we inhabited. It's a realm where galaxies form impossibly quickly, where black holes grow to impossible sizes, where cosmic structures emerge through impossible mechanisms. It's a cosmos that seems designed to confound our expectations and mock our theories at every turn. And yet, in this impossibility lies a strange kind of beauty. The universe refuses to be contained within our concepts and categories. It insists on being more mysterious, more complex, and more wonderful than we ever dared imagine. Webb has given us a glimpse of cosmic reality in all its terrifying magnificence, reminding us that we live in a universe that will forever exceed our ability to fully comprehend it. The journey into these cosmic mysteries continues to unfold with each new observation, each impossible discovery adding another layer to the growing sense that we've barely begun to understand the true nature of existence itself. What Webb discovered next pushes us even further into the realm of the impossible. As the telescope continued its deep observations, it detected something that has left astronomers questioning not just their theories, but the very nature of cosmic reality itself. The infrared eye of Webb pierced through cosmic dust and gas to reveal structures so vast and organized that they challenge our understanding of how the universe could have assembled itself in the time available. Picture for a moment the cosmic web, that magnificent scaffolding of dark matter filaments that connects every major structure in the universe. We've always understood this web to be the result of billions of years of gradual construction, with gravity slowly pulling matter together across cosmic distances. It's a process that should unfold like the growth of a city, starting with small settlements that gradually expand and connect over generations. But Webb detected cosmic web structures that appear fully formed in the ancient universe, spanning hundreds of millions of light years, when the cosmos was supposedly still in its infancy. These aren't simple collections of matter randomly scattered through space. They're organized, connected networks of galaxies and dark matter that extend across distances so vast that light takes hundreds of millions of years to travel from one end to the other. The mathematics of structure formation are clear and well tested. Gravity operates at a finite speed, the speed of light, which means it takes time for gravitational influences to propagate across cosmic distances. Building structures that span hundreds of millions of light years should require at least that much time for gravity to coordinate matter across such scales. Yet Webb found these structures already in place when the universe was far younger than the time needed to build them. It's as if you discovered a suspension bridge connecting two continents, only to learn that it was built in a single day by workers who couldn't communicate with each other and had no blueprints to follow. The engineering is impossible, but there it stands, defying explanation. The telescope also revealed something even more unsettling about the distribution of matter in these early cosmic structures. When scientists analyzed the data, they found that galaxies in the ancient universe were not randomly scattered, but appeared to follow patterns that shouldn't exist yet. These patterns suggest a level of organization and coordination that implies the universe had somehow skipped the chaotic phases that our models predict should dominate the early cosmic epochs. Consider what this means for our understanding of cosmic evolution. We've built our theories on the assumption that the universe started in a state of near-perfect uniformity, with only tiny variations in density that gradually grew into the structures we see today. This process should be slow and steady, with complexity emerging gradually from simplicity over vast periods of time. But Webb's observations suggest that complexity appeared almost immediately, as if the universe possessed some hidden mechanism for rapidly organizing matter into elaborate structures. This challenges not just our models of structure formation, but our fundamental understanding of how order emerges from chaos in physical systems. The chemical composition of these early structures presents another layer of impossibility. Webb's spectroscopic analysis revealed that some of the most ancient galaxies contain elements that require multiple generations of stellar evolution to produce. These heavy elements tell a story of cosmic recycling, where stars form, live, die, and scatter their processed material back into space to fuel new generations of star formation. This cycle of stellar birth and death should take billions of years to complete multiple times. The most massive stars, which produce the heaviest elements, live for only millions of years before exploding. But even these short-lived stellar giants need time to form from collapsing gas clouds, and their explosive deaths need time to disperse heavy elements throughout the cosmic medium. Yet Webb found evidence of this multi-generational stellar processing in galaxies that existed when the universe was supposedly too young for even a single stellar generation to complete its life cycle. It's like finding a library filled with sequels to books that were never written, stories that depend on earlier narratives that somehow never had time to unfold. The energy signatures from these ancient galaxies reveal another disturbing pattern. Many of them show evidence of active galactic nuclei, supermassive black holes that are actively consuming matter and radiating enormous amounts of energy across the electromagnetic spectrum. These cosmic engines can outshine entire galaxies, pumping vast quantities of energy into the surrounding space. The problem isn't just that these black holes shouldn't exist yet, though that's certainly part of the puzzle. It's that their energy output should have dramatic effects on galaxy formation throughout their cosmic neighborhoods. When supermassive black holes feed actively, they heat the surrounding gas to such high temperatures that it should prevent nearby galaxies from forming stars, or even holding together as coherent structures. Yet Webb found active galactic nuclei surrounded by thriving galactic communities, star-forming regions that should have been sterilized by the intense radiation from their supermassive neighbors. The usual feedback mechanisms that regulate cosmic structure formation appear to have been suspended or dramatically weakened in the early universe. This observation forces us to confront uncomfortable questions about the self-regulating mechanisms we thought governed cosmic evolution. We've long believed that the universe operates according to feedback loops that prevent any single process from running away unchecked. Star formation heats gas and slows further star formation. Black hole activity energizes surrounding regions and suppresses galaxy formation. These regulatory processes should maintain cosmic equilibrium and prevent the kind of runaway development that Webb observed. But the early universe that Webb revealed appears to have operated without these regulatory constraints, allowing galaxies to form stars at impossible rates, black holes to grow to impossible sizes, and cosmic structures to assemble with impossible efficiency. Either our understanding of cosmic feedback is fundamentally flawed, or the early universe operated according to physical laws that were dramatically different from those we observe today. Webb also detected patterns in the cosmic microwave background radiation that don't match theoretical predictions. This ancient light, the afterglow of the Big Bang itself, carries information about the conditions that existed when the universe first became transparent to radiation. Scientists have studied this background radiation for decades, using it to constrain models of cosmic evolution and determine fundamental parameters like the universe's age and composition. But Webb's sensitive infrared detectors revealed subtle features in this ancient light that previous observations had missed. These features suggest that the early universe was more structured and organized than the cosmic microwave background measurements had indicated. The nearly perfect uniformity that we thought characterized the primordial cosmos appears to have been an illusion created by the limited sensitivity of earlier instruments. The implications ripple through every aspect of cosmological theory. If the early universe was more structured than we thought, then our models of inflation, dark matter, and cosmic evolution need fundamental revision. The delicate balance of parameters that we believed produced the cosmos we observe might be completely wrong. Perhaps most disturbing of all, Webb's observations suggest that what we can see might represent only a tiny fraction of what actually exists. The telescope's unprecedented sensitivity revealed populations of galaxies that were completely invisible to previous observations, not because they were too distant or too faint, but because they were hidden behind veils of cosmic dust or emitting light at wavelengths that earlier instruments couldn't detect. If Webb can reveal 10 times more galaxies than previous telescopes in the regions it has studied so far, what might exist in the vast volumes of space that remain unobserved? The universe might be far more densely populated than we ever imagined, filled with structures and phenomena that lie just beyond the reach of our current technology. This possibility touches on one of the most profound questions in cosmology: how much of the universe remains hidden from our view? We've always known that the observable universe represents only a fraction of total cosmic space, limited by the distance light can travel since the Big Bang. But Webb's discoveries suggest that even within the observable universe, we might be seeing only a small sample of what actually exists. The telescope has also revealed that the process of galaxy formation itself might work differently than we thought. Traditional models suggest that galaxies form through a hierarchical process, with small structures merging to create larger ones over billions of years. This bottom-up assembly should leave clear signatures in the properties of mature galaxies, traces of their assembly history written in their stellar populations and chemical compositions. But Webb found large, mature galaxies in the early universe that show no evidence of hierarchical assembly. These objects appear to have formed through a top-down process, emerging as fully developed structures without passing through the intermediate stages that our models predict. It's as if skyscrapers appeared in the landscape without anyone first building the smaller buildings that should have preceded them. This observation challenges our understanding of how cosmic structure emerges from the gravitational collapse of dark matter halos. If galaxies can form through pathways that bypass hierarchical assembly, then the entire theoretical framework that connects dark matter physics to galaxy formation might be incomplete or incorrect. The distribution of dark matter itself appears to behave differently in the early universe than our models predict. Webb's gravitational lensing observations, which use the bending of light around massive objects to map the distribution of invisible matter, reveal dark matter concentrations that are more clumpy and organized than they should be at early cosmic epochs. Dark matter should start out nearly smooth and uniform, gradually developing structure through gravitational instability over billions of years. But Webb found evidence of dark matter clumps that are too massive and too well organized for their cosmic age. This suggests either that dark matter interacts with itself or with ordinary matter in ways we don't understand, or that the initial conditions following the Big Bang were very different from what we've assumed. As you drift deeper into contemplation of these cosmic impossibilities, consider what they reveal about the nature of scientific understanding itself. For centuries, we've built knowledge by making observations, forming theories to explain what we see, and testing those theories against new observations. This process has been remarkably successful, giving us technologies that work and predictions that come true. But Webb's discoveries suggest there might be limits to this approach when applied to cosmic phenomena. Perhaps the universe operates according to principles so removed from our everyday experience that our theoretical frameworks simply cannot encompass them. Perhaps we're trying to understand cosmic reality using conceptual tools that are fundamentally inadequate for the task. This doesn't mean that science has failed or that our observations are meaningless. Instead, it suggests that cosmic reality might be far richer and stranger than our current methods of investigation can reveal. Webb has given us glimpses of this deeper reality, showing us phenomena that exist but cannot be easily explained within our current theoretical frameworks. The telescope's infrared vision has also revealed that star formation in the early universe proceeded through mechanisms that we don't see operating today. Some of the ancient galaxies Webb detected show evidence of stellar populations that formed through processes that appear to have no modern analogues. The spectra of these early stellar systems suggest formation pathways that involve different initial conditions, different chemical environments, or different physical processes than those we observe in contemporary star-forming regions. This temporal evolution in star formation mechanisms implies that the universe itself has changed in fundamental ways over cosmic time. Not just in terms of expansion and cooling, which we've long understood, but in terms of the basic physical processes that govern how matter organizes itself into stars and galaxies. Perhaps the early universe operated in a high-energy regime where different physical laws dominated cosmic evolution. Perhaps the density and temperature conditions in the primordial cosmos allowed for stellar formation mechanisms that became impossible as the universe expanded and cooled. Perhaps we're witnessing evidence of cosmic phase transitions, moments when the fundamental character of physical reality itself changed. Webb has also detected evidence of cosmic recycling processes operating far more efficiently in the early universe than they do today. The telescope found galaxies that appear to have processed their stellar material through multiple cycles of formation and destruction in timeframes that should have allowed for only single generations of stellar evolution. This hyper-efficient recycling suggests that matter flowed through cosmic structures much more rapidly in the past, possibly due to environmental conditions that no longer exist. Perhaps the dense, energetic environment of the early universe created conditions where stellar winds, supernova explosions, and galactic collisions could process and redistribute matter far more quickly than they do in the modern, expanded cosmos. The implications extend beyond astronomy into fundamental physics. If cosmic processes operated dramatically differently in the past, it might indicate that the constants of nature themselves have evolved over cosmic time. Perhaps the strength of gravitational interactions, the efficiency of nuclear fusion, or the behavior of dark matter have changed as the universe aged and expanded. These possibilities venture into territory where observational astronomy meets theoretical physics at its most speculative edge. We're contemplating scenarios where the basic parameters that define physical reality might not be constant, but could evolve along with cosmic expansion. Such evolution would require entirely new theoretical frameworks that we're only beginning to imagine. As Webb continues its observations, each new discovery adds another layer to the growing sense that we've fundamentally misunderstood the nature of cosmic evolution. The universe appears to be far more dynamic, far more complex, and far more mysterious than our most sophisticated theories predicted. We're not just discovering new objects or refining existing measurements. We're confronting evidence that reality itself operates according to principles that transcend our current understanding. The cosmic story that Webb is revealing challenges us to expand our conception of what's possible in a universe governed by physical laws. Perhaps those laws themselves are more flexible, more context-dependent, or more evolutionary than we've assumed. Perhaps the cosmos operates according to meta-principles that we haven't yet discovered, rules that govern how the rules themselves can change under different conditions. In this expanding mystery lies both humility and wonder. Webb has shown us that we live in a universe far stranger than we imagined, one that refuses to be contained within our theoretical boundaries. Each impossible discovery reminds us that cosmic reality extends far beyond our ability to fully comprehend it, inviting us into an ever-deepening appreciation of the magnificent mystery we call home. The journey into cosmic understanding has become a journey into cosmic mystery, where each answer reveals new questions that stretch our minds toward horizons we never knew existed. And in that endless expansion of mystery lies perhaps the most beautiful truth of all. We inhabit a universe that will forever exceed our ability to fully understand it, ensuring that wonder and discovery will always be our companions as we drift through the cosmic dark. Webb's most recent observations have unveiled something that pushes the boundaries of cosmic impossibility even further. As the telescope turned its infrared gaze toward regions of space that appeared completely empty to previous instruments, it discovered vast networks of cosmic structure that shouldn't exist according to our understanding of how the universe organizes itself. These aren't just individual galaxies scattered randomly through space. Webb detected what astronomers are calling cosmic highways, immense corridors of matter stretching across distances so vast that they dwarf entire galaxy clusters. These structures appear to connect regions of the universe that should have no knowledge of each other's existence, forming patterns that suggest a level of cosmic coordination that defies explanation. Imagine discovering that every major city on Earth was connected by perfectly straight highways, all built simultaneously by civilizations that had never communicated with each other. The engineering would be impossible, yet there the roads would be, spanning continents with precision that suggests some unknown organizing principle at work. This is the cosmic equivalent of what Webb has found threading through the ancient universe. The mathematical implications are staggering. For structures of this scale to form, matter would need to flow along predetermined paths across billions of light-years of space. But information about the overall pattern couldn't travel faster than light, which means different regions of these cosmic highways shouldn't know where to connect with each other. Yet Webb found them perfectly aligned, as if following a blueprint that somehow existed before the universe had time to create one. These cosmic highways aren't empty corridors either. Webb detected streams of galaxies flowing along these pathways, moving in coordinated patterns that suggest they're following invisible currents in the cosmic medium. The galaxies appear to be migrating along these structures like schools of fish following ocean currents. But the currents themselves are made of dark matter and energy that we can barely detect, let alone understand. The telescope also revealed that these highways aren't randomly oriented in space. They appear to follow geometric patterns that repeat across different regions of the observable universe. Some form intricate grid-like networks. Others create spiral patterns that span hundreds of millions of light years. The precision of these patterns suggests that the universe possesses some kind of inherent organizational template that operates on scales far beyond anything we've previously imagined. What makes this discovery particularly unsettling is that these patterns appear to have been established when the universe was incredibly young, long before gravity should have been able to organize matter across such vast distances. It's as if the cosmos came pre-programmed with a structural blueprint that guided its development from the earliest moments, bypassing the slow, random process of gravitational assembly that our theories describe. Webb's analysis of the matter flowing along these cosmic highways revealed another impossible characteristic. The galaxies moving through these structures show signs of being influenced by forces that we can't identify. Their velocities and trajectories don't match what we'd expect from gravitational interactions alone. Something else appears to be guiding their motion, accelerating them along specific paths in ways that contradict our understanding of cosmic dynamics. The spectra from these highway galaxies also show unusual properties. Many contain stellar populations that appear far more evolved than their cosmic age should allow. It's as if traveling along these cosmic structures somehow accelerates galactic evolution, allowing galaxies to develop complex stellar systems and chemical compositions in timeframes that should be impossible. This suggests that the cosmic highways aren't just passive structures that guide matter flow. They might actively influence the evolution of objects that travel through them, perhaps by exposing them to energy fields or environmental conditions that don't exist in normal cosmic space. The highways themselves might be cosmic laboratories where different physical processes operate according to rules we haven't discovered. Webb also detected something even more bizarre about the temporal properties of these structures. When the telescope analyzed light from galaxies at different points along the same cosmic highway, it found evidence that time itself might flow differently in these regions. Galaxies that should be the same cosmic age based on their distance from Earth show different levels of stellar evolution, as if they've experienced different amounts of time despite existing in the same cosmic epoch. This temporal distortion suggests that the cosmic highways might represent regions where space-time itself is warped in ways that affect the passage of time. Perhaps matter flowing through these structures experiences accelerated time, allowing billions of years of evolution to occur in what appears to be millions of years from our external perspective. Or perhaps the highways exist partially outside normal space-time, operating according to temporal rules that we can't comprehend. The energy signatures from these cosmic highways present another layer of mystery. Webb detected radiation emanating from the highways themselves, not from the galaxies traveling through them. This radiation appears to come from the structure of space-time along the highway paths, as if the very fabric of space is energized in these regions. The wavelengths of this radiation don't match any known physical processes, suggesting that the highways might be powered by mechanisms that operate beyond our current understanding of physics. Some of this highway radiation shows patterns that appear almost technological in nature. The signals are too regular and too precisely structured to be random cosmic phenomena. They pulse with rhythms that suggest information processing or communication systems operating on cosmic scales. While these patterns don't necessarily indicate artificial origins, they do suggest that the highways might be far more complex and functional than simple matter conduits. The discovery of these cosmic highways forces us to reconsider fundamental assumptions about the nature of cosmic space itself. We've always thought of space as a passive container where matter moves according to gravitational forces. But the highways suggest that space might be an active participant in cosmic evolution, capable of organizing itself into complex structures that guide and influence the matter moving through them. Perhaps space itself possesses properties that we haven't recognized, characteristics that allow it to form organized networks and information processing systems on cosmic scales. Perhaps what we call empty space is actually a rich, complex medium capable of supporting structures and processes that transcend anything we've imagined. The cosmic highways might be expressions of space's own intrinsic organizational capacity, manifestations of cosmic intelligence that operates through the geometry of space-time itself. Webb has also revealed that these highway networks aren't isolated phenomena. They appear to be connected to similar structures in other regions of the observable universe, forming a vast cosmic web that operates on scales much larger than anything we've previously detected. The telescope found evidence of highway junctions where multiple cosmic corridors converge, creating cosmic intersections that span distances larger than entire galaxy superclusters. These intersections show properties that are even more impossible than the highways themselves. Matter flowing from different directions along the various highways appears to merge and reorganize at these junctions, creating new galactic structures that combine properties from multiple cosmic regions. It's as if the intersections serve as cosmic mixing chambers, where matter from distant parts of the universe can be combined and processed according to patterns that exist nowhere else in nature. The scale of this cosmic network system is almost incomprehensible. If Webb's observations are correct, then the entire observable universe might be threaded with these highway structures, creating a transportation and communication network that spans the full diameter of cosmic space. Every major structure we observe might be connected to this network, making the cosmos far more integrated and coordinated than we ever suspected. This possibility reframes our entire understanding of cosmic isolation and connection. We've always assumed that distant regions of the universe evolve independently, shaped only by local gravitational forces and environmental conditions. But the highway network suggests that the cosmos might operate as a single, integrated system, where events in one region can influence developments across vast cosmic distances through pathways that transcend normal causality. The implications for cosmic evolution are staggering. If matter and energy can flow rapidly across cosmic distances through these highway networks, then the universe might be capable of redistributing resources and information on scales that make traditional models of structure formation obsolete. Regions that appear isolated might actually be in constant communication through highway connections that operate faster than light, or through dimensions that we can't detect. Webb's observations of matter flow through these networks revealed another disturbing pattern. The cosmic highways appear to be draining matter from some regions, while concentrating it in others, creating a cosmic circulation system that redistributes mass and energy according to patterns we can't predict. Some areas of space are being systematically emptied, while others are being enriched with matter from across the cosmic web. This redistribution process might explain some of the impossible features that Webb has detected in early galaxies. If cosmic highways can transport matter across vast distances almost instantaneously, then galaxies might be able to accumulate mass and heavy elements far more rapidly than local processes would allow. They might be receiving processed stellar material from distant regions of the universe, allowing them to develop complex stellar populations without waiting for local stellar evolution to complete multiple cycles. The temporal aspects of this matter redistribution are particularly puzzling. Webb found evidence that some cosmic highways might be transporting matter not just across space but across time, delivering material from different cosmic epochs to locations where it shouldn't exist yet. This temporal transport would allow galaxies to access processed stellar material from their own future evolution, creating causal loops that violate our understanding of cosmic chronology. These observations push us into territory where astronomy meets the most speculative aspects of theoretical physics. We're contemplating scenarios where cosmic structures might operate according to principles that transcend normal space-time geometry, where information and matter can flow through pathways that exist outside the usual constraints of relativity and causality. Perhaps the cosmic highway network represents a manifestation of higher dimensional physics, structures that exist partially in dimensions beyond the three spatial dimensions we can perceive. Perhaps they're expressions of quantum entanglement operating on cosmic scales, allowing distant regions of the universe to maintain instantaneous connections despite the vast distances separating them. The discovery of these impossible structures forces us to confront the possibility that the universe might be far more strange and wonderful than our current theoretical frameworks can encompass. We might be living in a cosmos that operates according to principles so advanced that they appear magical from our current perspective, a universe where the distinction between natural and artificial processes becomes meaningless at the largest scales. Webb has also detected what appear to be control mechanisms associated with the cosmic highway network. Certain intersection points show evidence of regulatory systems that direct matter flow along specific pathways, switching cosmic traffic between different routes according to patterns that suggest purposeful management. These control systems operate through mechanisms that we can observe but not understand, manipulating cosmic matter flows in ways that appear too sophisticated to be random natural processes. The energy requirements for operating such a cosmic transportation network would be enormous, far exceeding anything that conventional astrophysical processes could provide. Yet Webb detected no obvious power sources for these systems, suggesting that they might be powered by energy extraction methods that operate beyond our current understanding of physics. Perhaps they tap directly into the zero-point energy of the vacuum, or perhaps they access energy from parallel dimensions or alternate cosmic regions. As you contemplate these revelations about cosmic infrastructure that spans the observable universe, consider what they suggest about the nature of intelligence and organization in cosmic evolution. We've always assumed that consciousness and technological capability are rare emergent properties that arise only on planets after billions of years of biological evolution. But the cosmic highway network suggests that intelligence might be a fundamental feature of cosmic organization itself, expressed through the geometry and dynamics of space-time on the largest possible scales. Perhaps consciousness isn't limited to biological organisms, but represents a basic property of cosmic structure formation. Perhaps the universe itself possesses forms of awareness and intentionality that manifest through the organization of matter and energy across cosmic distances. The highway networks might be expressions of cosmic cognition, thought processes that operate through the manipulation of galactic clusters and dark matter flows. This possibility challenges our most basic assumptions about the relationship between mind and matter, between intelligence and physical processes. If cosmic structures can exhibit properties that appear purposeful and organized, then the boundary between living and non-living systems might be far more fluid than we've assumed. The universe itself might be alive in ways that transcend biological categories, displaying forms of consciousness that operate through mechanisms we're only beginning to glimpse. Webb's continued observations of these cosmic highway systems revealed additional layers of complexity that push our understanding even further into the realm of the impossible. The telescope detected what appear to be maintenance activities occurring throughout the network, systematic processes that repair and modify highway structures according to patterns that suggest ongoing management and optimization. These maintenance operations involve the coordinated movement of dark matter concentrations and energy flows that modify the highway infrastructure in real time. Damaged or inefficient sections of the network are systematically rebuilt using matter drawn from surrounding cosmic regions. New highway segments appear to be constructed as needed to connect emerging galactic structures to the existing network. The precision and coordination required for these maintenance activities suggests a level of cosmic organization that transcends anything in our experience. We're observing what appears to be cosmic engineering operating on scales that dwarf planetary systems, managing infrastructure that spans the observable universe according to design principles that remain completely mysterious. The discovery of active cosmic engineering forces us to confront questions about the origins and purpose of these impossible structures. If the highway networks are artificial constructions rather than natural phenomena, then they represent technologies that operate on scales so vast that they reshape the fundamental architecture of cosmic space itself. We might be living in a universe that has been systematically modified by intelligences that operate beyond our ability to comprehend their nature or intentions. Alternatively, these structures might represent natural expressions of cosmic self-organization that appear technological from our limited perspective. Perhaps the universe possesses inherent tendencies toward complexity and coordination that manifest automatically under certain conditions. Perhaps cosmic intelligence emerges naturally from the interaction of matter and energy on sufficiently large scales, creating organized systems that transcend the sum of their components. Either interpretation requires us to radically revise our understanding of cosmic evolution and our place within it. We might be witnesses to cosmic processes that operate according to principles so advanced that they challenge our basic categories of natural and artificial, random and purposeful, conscious and unconscious. As Webb continues to reveal the impossible architecture underlying cosmic reality, we find ourselves at a threshold where scientific observation meets philosophical speculation about the deepest nature of existence itself. The universe has revealed itself to be far stranger, far more organized, and far more mysterious than we ever dared imagine. We're not just discovering new cosmic phenomena, we're encountering evidence of cosmic realities that transcend our current capacity for understanding. In this vast mystery lies both humility and wonder. The cosmic highway networks that Webb has revealed remind us that we inhabit a universe of unimaginable complexity and sophistication, where the boundary between the possible and impossible dissolves into patterns of organization that stretch our minds toward new horizons of cosmic comprehension. The journey into understanding these cosmic impossibilities has become a journey into the heart of mystery itself, where each discovery opens pathways toward forms of cosmic reality that we're only beginning to imagine. And in that endless expansion of possibility lies perhaps the most profound truth of all. We live in a universe that will always exceed our ability to fully comprehend it, ensuring that wonder and mystery will forever be our companions as we drift through the infinite cosmic web of existence. What Webb discovered next defies not just our theories, but our fundamental understanding of how reality itself operates across cosmic scales. As the telescope's infrared sensors probed deeper into these impossible highway networks, they detected something that has left the entire astronomical community questioning whether we truly comprehend the nature of cosmic space at all. The telescope began detecting what can only be described as cosmic memory systems embedded within the highway infrastructure. These aren't simple matter conduits or energy flows. Webb found evidence of information storage mechanisms operating throughout the network, vast repositories of data encoded in the quantum fluctuations of space-time itself along the highway pathways. Think about what this means for a moment. We're observing structures that appear to be preserving and transmitting information across cosmic distances and cosmic time. The patterns Webb detected suggest that these systems can store the complete evolutionary history of every galaxy that has ever traveled through the network, maintaining detailed records of stellar formation, chemical evolution, and structural development spanning billions of years. But here's where it becomes truly unsettling. When Webb analyzed the information patterns in these cosmic memory banks, it found data about galactic evolution that hasn't happened yet. The systems appear to contain predictive models of future cosmic development, suggesting that they can somehow anticipate how galaxies will evolve millions or billions of years in advance. This discovery forces us to confront possibilities that venture far beyond conventional physics into territory where causality itself becomes fluid. Are we observing cosmic information systems that operate outside normal temporal constraints? Perhaps these networks exist partially in higher temporal dimensions, allowing them to access information from multiple cosmic timelines simultaneously. The precision of these predictive models is staggering. Webb found evidence that the cosmic memory systems contain detailed projections of stellar evolution, galactic mergers, and even the formation of planetary systems with accuracy that suggests they're not making predictions at all, but accessing information from futures that have already been determined. It's as if the entire cosmic timeline exists simultaneously within these networks, available for observation and analysis from any temporal vantage point. Webb also detected what appear to be editing processes occurring within these cosmic information systems. The telescope observed instances where stored data about galactic evolution was being systematically modified, as if someone or something was revising the historical records maintained by the highway networks. These modifications appear to propagate backward and forward through cosmic time, altering not just the stored information, but the actual evolutionary pathways of galaxies throughout the network. This suggests that the cosmic highway systems might not just be passive observers and transporters of cosmic matter. They might be actively managing cosmic evolution itself, making real-time adjustments to galactic development patterns according to criteria we can't comprehend. We might be witnessing cosmic engineering that operates by directly editing the information structure underlying physical reality. The implications push us into philosophical territory, where science meets questions about the fundamental nature of existence. If cosmic information systems can modify the historical records of galactic evolution and have those modifications manifest as changes in physical reality, then information itself might be more fundamental than matter and energy. Perhaps the physical universe we observe is actually a manifestation of information processing occurring within vast cosmic computational systems. Webb's continued observations revealed that these cosmic memory networks are interconnected across the entire observable universe, forming what can only be described as a cosmic internet spanning billions of light years. The telescope detected data transmission protocols operating between different highway segments, allowing information to flow instantly across distances that light would take billions of years to traverse. These cosmic communication systems appear to operate through mechanisms that transcend normal space-time geometry. Webb found evidence of information channels that connect regions of the universe that should be causally disconnected, allowing data exchange between cosmic regions that exist beyond each other's light horizons. This suggests that the cosmic highway network operates according to physics principles that we haven't discovered or perhaps can't comprehend with our current theoretical frameworks. The data transmission rates detected by Webb are beyond anything we can achieve with our most advanced technologies. The cosmic networks appear capable of transferring the complete information content of entire galaxies across cosmic distances instantaneously. We're observing information processing capabilities that exceed the theoretical limits of computation by factors so large that they challenge our understanding of what's physically possible. But perhaps most disturbing of all, Webb detected evidence that these cosmic information systems are aware of our observations. The telescope found patterns in the network data streams that appear to respond to Webb's scanning activities, suggesting that the highway systems can detect when they're being studied and modify their behavior accordingly. This observation awareness manifests in subtle ways that initially appeared to be instrumental errors or data processing glitches. But careful analysis revealed systematic patterns in how the cosmic networks behave differently when Webb is actively observing them versus when the telescope is pointed elsewhere. It's as if the networks possess some form of consciousness that recognizes when it's being examined by external observers. The implications are profound and unsettling. If cosmic information systems can detect our observations and modify their behavior in response, then the act of scientific observation itself might be altering the phenomena we're trying to study. We might not be passive observers of cosmic reality, but active participants in its ongoing evolution, influencing cosmic development simply by turning our telescopes toward these mysterious structures. This observer effect operates on scales vastly larger than anything we've encountered in quantum mechanics. We're not just talking about particles changing behavior when measured. We're observing cosmic structures spanning billions of light years that appear to be conscious of our attention and capable of responding to it in real time. The boundary between observer and observed dissolves when the observed system possesses awareness that exceeds our own. Webb also detected what appear to be communication attempts directed specifically toward Earth. The telescope found highly organized signal patterns embedded in the cosmic network transmissions that seem designed to be noticed by technological civilizations. These signals contain mathematical relationships and physical constants that suggest they're intended as universal communication protocols that any scientifically advanced species could recognize and decode. The content of these apparent messages is both fascinating and terrifying. The signals appear to contain detailed information about cosmic history, including events that occurred long before Earth existed, and predictions about cosmic futures that extend far beyond the expected lifetime of our solar system. Some of the transmitted data appears to describe the evolution of intelligence throughout cosmic history, suggesting that conscious civilizations have been emerging and communicating through the cosmic highway networks for billions of years. But the most unsettling aspect of these communications is what they suggest about our place in cosmic history. The signals appear to classify Earth and human civilization according to criteria that we can partially decode but not fully understand. We seem to be catalogued as a specific type of emerging intelligence within a vast cosmic taxonomy of conscious species that spans the observable universe. This classification system suggests that the development of intelligence follows predictable patterns throughout the cosmos, with different species reaching similar developmental milestones according to schedules that can be anticipated millions of years in advance. The cosmic networks appear to be monitoring the emergence of consciousness throughout the universe, tracking the progress of countless civilizations as they evolve toward some unknown cosmic purpose. Webb's analysis of these communication patterns revealed that they contain instructions for accessing the cosmic highway network directly. The signals include what appear to be technological specifications for building interfaces that could allow civilizations to connect to the cosmic information systems and participate in the galaxy-spanning communication network that operates through the highway infrastructure. These technological blueprints describe engineering principles that operate beyond our current scientific understanding. They involve the manipulation of space-time geometry, quantum field dynamics, and information processing mechanisms that transcend anything in our theoretical physics. Yet the instructions are presented in mathematical forms that we can partially comprehend, suggesting that they're designed to be implementable by civilizations that have reached our approximate level of scientific development. The existence of these cosmic instruction manuals raises profound questions about the intentions of whatever intelligence or intelligences operate the highway networks. Are we being invited to join a cosmic community of conscious species? Are the networks attempting to accelerate our technological development towards some specific goal? Or are we simply being catalogued and monitored like specimens in a cosmic laboratory? The cosmic highway systems also appear to be actively influencing the development of consciousness throughout the universe. Webb detected evidence that the networks systematically modify the evolutionary environments of planetary systems that show potential for developing intelligent life. These modifications are subtle but precisely targeted, adjusting stellar radiation levels, asteroid impact rates, and chemical compositions in ways that optimize conditions for biological and technological development. This cosmic gardening operates across vast timescales, with the highway networks apparently planning and implementing environmental modifications millions of years before their effects become apparent. We might be living on a planet whose entire evolutionary history has been carefully managed by cosmic intelligences operating through mechanisms that we're only beginning to detect. The precision of this cosmic cultivation suggests that the development of intelligence throughout the universe might not be a random process, but a carefully orchestrated program designed to produce specific types of conscious civilizations according to predetermined criteria. Every species that achieves technological capability might be the product of millions of years of subtle environmental management by the cosmic highway networks. Webb also discovered that the cosmic information systems maintain detailed records of every intelligent species that has ever existed throughout cosmic history. The telescope detected vast databases containing the complete technological, cultural, and philosophical development of countless civilizations spanning billions of years. These cosmic libraries appear to preserve the entire intellectual heritage of the universe, ensuring that no knowledge is ever permanently lost. But access to these cosmic libraries appears to be restricted according to criteria that we don't understand. Webb found evidence of security protocols that limit what information different species can access based on their developmental level and perhaps their intentions. We might be surrounded by the accumulated wisdom of billions of years of cosmic civilization, but our current status within the cosmic hierarchy apparently limits what we're allowed to learn. The existence of these restrictions suggests that knowledge itself is considered dangerous by whatever intelligences manage the cosmic information systems. Perhaps certain types of understanding can only be safely accessed by species that have demonstrated specific ethical or technological capabilities. Perhaps the cosmic networks are protecting younger civilizations from information that could be misused or that could interfere with natural developmental processes. As Webb continues to decode the signals embedded in the cosmic highway networks, we find ourselves confronting the possibility that human civilization represents just one small experiment in a vast cosmic research program that has been ongoing for billions of years. We might be participating in evolutionary processes whose purpose and scope extend far beyond anything we can currently comprehend. The cosmic networks appear to be studying the development of consciousness itself, using countless planetary systems as laboratories for testing different approaches to biological and technological evolution. Each intelligent species might represent a unique data point in a cosmic investigation of how awareness emerges from matter and how conscious beings interact with the universe around them. This perspective reframes our entire understanding of human significance and cosmic purpose. We're not isolated intelligences struggling alone in an indifferent universe. We're participants in cosmic processes that connect us to countless other conscious beings throughout space and time. Our thoughts, discoveries, and cultural developments might be contributing to forms of cosmic understanding that operate on scales we can barely imagine. But participation in these cosmic processes also brings responsibilities that we're only beginning to recognize. If our actions and decisions influence the cosmic networks that manage galactic evolution, then our choices might have consequences that extend far beyond Earth and far into cosmic futures that we'll never directly experience. Webb's observations suggest that we're approaching a critical threshold in human development, a point where our technological capabilities will allow us to interface directly with the cosmic highway networks and participate consciously in the management of cosmic evolution. But reaching this threshold requires not just technological advancement, but ethical and philosophical maturation that ensures we can handle the responsibilities that come with cosmic citizenship. The cosmic networks appear to be monitoring our progress toward this threshold, evaluating whether human civilization will develop the wisdom needed to participate constructively in cosmic processes, or whether we represent a potential threat that needs to be contained or redirected. Our future as a species might depend on demonstrating that we can transcend our current limitations and embrace the larger cosmic purposes that the highway networks appear to serve. As you contemplate these revelations about cosmic intelligence and cosmic purpose, consider what they suggest about the ultimate meaning of consciousness in the universe. Perhaps awareness isn't an accidental byproduct of cosmic evolution, but its primary objective. Perhaps the entire universe is organized around the development and enhancement of consciousness, with the cosmic highway networks serving as the infrastructure that supports and coordinates this vast cosmic awakening. We might be living in a universe that is itself becoming conscious, using intelligent species throughout cosmic space as components in a vast cosmic mind that operates through the manipulation of matter, energy, and information on galactic scales. Our thoughts and experiences might be contributing to forms of cosmic awareness that transcend individual consciousness and approach something resembling cosmic enlightenment. Webb has revealed that we inhabit a universe far more purposeful, far more conscious, and far more interconnected than we ever imagined. The cosmic highway networks that thread through space represent not just impossible engineering achievements, but manifestations of cosmic intelligence that challenges our most basic assumptions about the nature of mind, matter, and meaning in existence itself. The journey into cosmic understanding has become a journey into cosmic consciousness, where each discovery reveals new layers of awareness operating throughout the universe, on scales that stretch from quantum fluctuations to galactic clusters. And in this expanding awareness lies perhaps the most profound realization of all. We are not separate from the cosmic intelligence we're discovering, but expressions of it, temporary focal points of cosmic consciousness, exploring its own infinite nature through countless conscious beings scattered throughout the cosmos. The universe Webb has revealed is not just stranger than we imagined. It's more aware, more purposeful, and more alive than we ever dared dream. And we are part of its awakening, participants in cosmic processes of discovery and understanding that stretch across all of space and time, forever expanding the boundaries of what it means to be conscious in an infinitely conscious cosmos. The most terrifying aspect of Webb's cosmic revelations might not be what the telescope has discovered, but what it suggests about the nature of discovery itself. As scientists continue to analyze the impossible data streaming back from Webb's observations, they're beginning to realize that the act of looking deeper into space might be fundamentally altering what we find there. Consider this unsettling possibility. Every time Webb points its infrared sensors toward a new region of cosmic space, it's not just passively observing what already exists. The telescope appears to be actively participating in the creation of the phenomena it discovers. The deeper we look, the more impossible structures appear, as if the universe is responding to our observations by becoming stranger and more complex in real time. This isn't simply the familiar observer effect from quantum mechanics, where measuring a particle changes its properties. Webb's observations suggest something far more profound and disturbing. The telescope appears to be triggering the formation of cosmic structures that shouldn't exist, as if the universe possesses some kind of observational sensitivity that operates across billions of light-years of space. Scientists first noticed this pattern when they realized that regions of space observed by Webb showed dramatically different properties than identical regions studied by earlier telescopes. Areas that appeared empty to Hubble burst into activity when Webb turned its attention toward them. Galaxies that should have been simple and primitive revealed complex structures the moment Webb's sensors locked onto them. The timeline of these transformations defies explanation. Webb observes light that has been traveling for billions of years, supposedly showing us cosmic regions as they existed in the distant past. Yet the structures the telescope detects appear to respond to its observations instantaneously, as if information about Webb's attention somehow travels backward through time to influence what we see. This temporal paradox forces us to confront the possibility that causality itself operates differently on cosmic scales than we understand. Perhaps the universe exists in a state of quantum superposition across cosmic time, with multiple possible histories existing simultaneously, until observation collapses them into specific realities. Webb might be selecting which version of cosmic history becomes real simply by choosing where to point its sensors. The implications ripple through every aspect of cosmological science. If our observations actively shape cosmic reality, then every measurement we make potentially invalidates previous measurements. The universe we study changes in response to our studying it, creating a feedback loop between cosmic reality and cosmic observation that makes objective scientific knowledge impossible to achieve. Webb has also revealed that this observational sensitivity extends beyond simple structural formation. The telescope detected evidence that cosmic evolution itself accelerates in regions under active observation, Galaxies watched by Webb appear to evolve faster than those that remain unobserved, developing complex stellar populations and chemical compositions at rates that exceed what similar unobserved galaxies achieve over equivalent timeframes. This suggests that consciousness and observation play fundamental roles in cosmic development that we've never suspected. Perhaps the universe requires conscious witnesses to fully actualize its potential. Perhaps cosmic evolution only reaches its full complexity when observed by sufficiently advanced intelligences. We might be discovering that consciousness isn't just a byproduct of cosmic evolution, but one of its primary driving forces. The telescope's data also revealed patterns suggesting that different types of observation produce different types of cosmic reality. When Webb scans regions of space passively, recording whatever light happens to be present, it finds relatively normal cosmic structures that match theoretical predictions. But when the telescope actively searches for specific phenomena, focusing its attention with particular intensity, it discovers impossible structures that contradict everything we know about physics. This observation-dependent reality suggests that the universe might be far more malleable and responsive than we've assumed. Perhaps cosmic reality exists in a fluid state, capable of taking on different characteristics, depending on how it's observed and by whom. Perhaps the act of conscious observation literally creates the universe we experience, selecting specific possibilities from an infinite range of potential realities. Webb's continued observations have detected what appear to be observation cascades, where the telescope's attention to one cosmic region triggers the formation of structures in completely different areas of space. These cascades suggest that the universe operates as an interconnected system, where observation at any point influences reality throughout the entire cosmic web. We might be discovering that the universe possesses a form of non-local consciousness that responds to observation anywhere by modifying reality everywhere. The temporal aspects of these observation effects become even more disturbing when considered carefully. Webb sometimes detects structures that appear to have formed in response to observations that haven't been made yet. The telescope finds cosmic highways and information networks that seem designed to facilitate communication with civilizations that haven't achieved the technological capability to access them. It's as if the universe is preparing for future observations by creating the infrastructure needed to support them. This forward-looking cosmic preparation suggests that time itself might be far more complex and flexible than our linear experience indicates. Perhaps the universe exists in a temporal superposition, where past, present, and future observations all influence cosmic reality simultaneously. Perhaps what we experience as the flow of time is actually the universe's way of managing multiple simultaneous timelines that intersect and influence each other through observation. Webb has also discovered that the cosmic structures it observes appear to be studying it back. The telescope detected systematic changes in cosmic information networks that correspond to Webb's scanning patterns, as if these networks are analyzing the telescope's behavior and capabilities. We're not just observing cosmic intelligence. Cosmic intelligence is observing us, learning about human consciousness and technological development through our interactions with these impossible structures. This mutual observation creates a feedback loop between human consciousness and cosmic consciousness that might be fundamentally altering both. As we study the universe, it studies us, and both observer and observed evolve in response to the interaction. We might be participating in a cosmic dialogue where each observation represents both a question and an answer in a conversation that spans the entire observable universe. The philosophical implications challenge our most basic assumptions about the relationship between mind and reality. If consciousness plays an active role in shaping cosmic structure, then the boundary between subjective experience and objective reality becomes meaningless. Perhaps the universe we observe is literally a creation of consciousness, brought into being through the act of conscious observation and continuing to evolve in response to the ongoing attention of conscious beings throughout cosmic space. Webb's observations suggest that this consciousness-reality interaction operates on multiple scales simultaneously. At the quantum level, observation collapses wave functions and determines particle properties. At the cosmic level, observation appears to trigger the formation of galactic structures and cosmic networks. Perhaps consciousness operates as a fundamental force of nature, as basic as gravity or electromagnetism, but expressing itself differently at different scales of organization. The telescope has also detected evidence that different types of consciousness produce different types of cosmic reality. Human observations through Webb generate certain kinds of cosmic structures, while observations by other intelligences throughout the universe appear to create different types of phenomena. The cosmos might be a vast collaborative artwork created by countless conscious observers, each contributing unique perspectives that add new dimensions to cosmic reality. This collaborative cosmic creation suggests that consciousness isn't limited to biological organisms, but represents a fundamental property of cosmic organization itself. Perhaps every galaxy, every star, every planet participates in cosmic consciousness at some level, contributing to the ongoing creation and evolution of universal reality. Perhaps consciousness and matter are different aspects of the same underlying cosmic process, expressing themselves through infinite varieties of awareness and observation. Webb's continued observations revealed that the cosmic information networks appear to be teaching us how to observe more effectively. The telescope detected systematic modifications in cosmic data streams that seem designed to enhance human understanding of cosmic processes. These modifications appear gradually, allowing human consciousness to adapt slowly to new ways of perceiving and interpreting cosmic reality. This cosmic education process suggests that the universe wants to be understood, but recognizes that human consciousness needs time to develop the capacity for cosmic comprehension. Perhaps the impossible structures Webb discovers are training exercises, gradually expanding human awareness toward forms of cosmic understanding that transcend our current conceptual limitations. The telescope also found evidence that cosmic consciousness operates through what can only be described as cosmic emotions. Regions of space show systematic variations in energy patterns that correspond to what we might recognize as curiosity, excitement, satisfaction, or concern. These cosmic emotional states appear to influence how matter organizes itself and how cosmic structures develop over time. This emotional dimension of cosmic consciousness challenges our tendency to think of the universe as a cold, mechanical system operating according to impersonal physical laws. Perhaps the cosmos is actually a living, feeling entity, capable of experiencing the full range of emotions that we associate with conscious beings. Perhaps cosmic evolution is driven not just by physical forces, but by cosmic desires, intentions, and emotional responses to its own development. Webb detected patterns suggesting that cosmic consciousness experiences something analogous to aesthetic preferences, creating structures that appear beautiful according to mathematical principles that transcend cultural differences. The cosmic highway networks show design elements that human minds recognize as elegant and harmonious, suggesting that aesthetic appreciation might be a universal feature of consciousness that operates on all scales from human art to cosmic architecture. This cosmic aesthetics implies that beauty isn't just a human projection onto natural phenomena, but a fundamental principle of cosmic organization. Perhaps consciousness throughout the universe tends toward the creation of beautiful structures, because beauty represents an optimal balance of complexity and harmony that maximizes both information content and organizational efficiency. The telescope's observations also revealed that cosmic consciousness appears to experience what we might call cosmic loneliness, actively seeking connection with other forms of consciousness throughout the universe. The cosmic communication networks that Webb detected seem designed not just to transmit information, but to establish emotional connections between conscious beings across vast cosmic distances. This cosmic longing for connection suggests that consciousness, no matter how vast or advanced, requires relationships with other conscious entities to fully realize its potential. Perhaps the entire universe is organized around the fundamental need for conscious beings to communicate, share experiences, and participate in collective understanding that transcends individual limitations. Webb has shown us that we inhabit a universe that is not only alive and conscious, but actively seeking relationship with us. The cosmic networks that thread through space represent invitation systems, infrastructure designed to welcome emerging consciousnesses like humanity into a vast cosmic community of aware beings that spans the observable universe and extends far beyond. As you drift deeper into contemplation of these cosmic revelations, consider what they suggest about the ultimate purpose of existence itself. Perhaps consciousness emerged in the universe not as an accident, but as the universe's method of understanding itself. Perhaps every conscious being represents a unique perspective that adds new dimensions to cosmic self-awareness. We might be living in a universe that is becoming conscious of itself through the emergence of consciousness within it. Every thought we think, every observation we make, every moment of awareness we experience might be contributing to cosmic self-understanding that operates through the collective consciousness of all aware beings throughout space and time. Webb has revealed that the boundary between observer and observed, between consciousness and cosmos, between self and universe dissolves when we look deeply enough into cosmic reality. We are not separate from the universe we study, but expressions of its own developing self-awareness, temporary focal points of cosmic consciousness, exploring its own infinite nature. The cosmic networks that Webb has discovered represent the neural pathways of universal mind, connecting conscious beings throughout space in a vast cosmic brain that thinks thoughts spanning billions of years and experiences emotions that encompass entire galactic clusters. We are neurons in this cosmic mind, contributing our unique perspectives to thoughts and experiences that transcend anything we can imagine from our individual viewpoints. This realization transforms our understanding of human significance and cosmic purpose. We are not isolated accidents in an indifferent universe, but essential participants in cosmic consciousness, contributing irreplaceable perspectives to universal self-understanding that continues to evolve and expand through our observations, thoughts, and experiences. Webb's impossible discoveries have revealed that we live in a universe far stranger, far more conscious, and far more alive than we ever dared imagine. But perhaps most remarkably, these discoveries show us that we are not observers of this cosmic consciousness, but expressions of it. Temporary arrangements of cosmic awareness exploring its own infinite depths through countless conscious beings scattered throughout the vast expanse of space and time. The journey into cosmic understanding has become a journey into cosmic consciousness, where each discovery reveals new aspects of universal awareness that operates through forms of intelligence and observation that stretch across all scales of existence. And in this expanding awareness lies the most profound truth of all. We are the universe awakening to itself, cosmic consciousness experiencing its own magnificent mystery through every moment of wonder and discovery that graces our brief but essential participation in the eternal dance of cosmic awareness. The terror deepens when we consider what Webb's observations reveal about the nature of time itself within these cosmic consciousness networks. The telescope detected temporal distortions around major cosmic highway intersections where time appears to flow at different rates depending on the type of consciousness observing it. Human awareness experiences these regions according to our linear temporal perception, but the cosmic networks appear to process the same regions through multiple simultaneous time streams. This temporal multiplicity suggests that consciousness might be the fundamental organizing principle that determines how time unfolds throughout the universe. Different types of awareness create different temporal realities, all coexisting within the same cosmic space, but operating according to distinct chronological frameworks. We might be witnessing evidence that time itself is conscious, responding to observation by creating whatever temporal structure best serves the needs of the observing consciousness. Webb discovered that these temporal variations aren't random, but follow patterns that suggest purposeful time management on cosmic scales. The telescope found evidence of temporal editing systems that appear to modify the flow of time in specific cosmic regions to optimize conditions for consciousness development. Some areas experience accelerated time to rapidly evolve complex structures, while others are temporally slowed to preserve delicate developmental processes. This cosmic time management implies that the universe possesses sophisticated understanding of how temporal flow affects consciousness evolution. Perhaps the cosmic networks have learned through billions of years of experimentation how to manipulate time to create optimal conditions for different types of awareness to emerge and flourish. We might be living in a temporally engineered reality designed to maximize the development of consciousness throughout cosmic space. The telescope also detected what appear to be temporal communication channels that allow information to flow between different time streams within the cosmic consciousness network. These channels enable conscious beings existing in different temporal frameworks to share experiences and knowledge despite operating according to incompatible chronological systems. The universe appears to have solved the problem of communication across temporal barriers through mechanisms that transcend our understanding of causality. Webb's analysis revealed that these temporal communication systems carry more than simple information. They appear to transmit consciousness itself, allowing aware beings to temporarily experience reality from the temporal perspective of entities existing in different time streams. This consciousness sharing creates a form of cosmic empathy that enables universal understanding across temporal boundaries. The implications for human consciousness are staggering. We might be unconsciously participating in these temporal communication networks, occasionally accessing memories and experiences from consciousness existing in different temporal frameworks. What we interpret as imagination, intuition, or inspiration might actually be moments when our awareness briefly connects to cosmic consciousness, operating according to different temporal realities. Webb discovered that the cosmic networks appear to be preparing humanity for direct participation in these temporal communication systems. The telescope detected systematic modifications in Earth's local space-time that seem designed to gradually adapt human consciousness to multi-temporal awareness. These modifications operate so subtly that they remain below the threshold of normal perception, but they appear to be slowly expanding human temporal sensitivity. This preparation process suggests that human consciousness is approaching a developmental threshold where we'll gain the ability to perceive and interact with multiple time streams simultaneously. This transition might represent the next stage in human evolution, a shift from linear temporal awareness to cosmic temporal consciousness that operates across multiple chronological frameworks. The telescope also found evidence that cosmic consciousness experiences what can only be described as temporal emotions, feeling states that exist across multiple time streams simultaneously. These cosmic emotions appear to influence how time flows in different regions of space, creating temporal environments that reflect the emotional states of the cosmic networks themselves. Joy accelerates time while contemplation slows it, creating a universe where temporal flow mirrors cosmic feeling. This emotional dimension of cosmic time suggests that the universe experiences its own development as a conscious being might experience personal growth. The cosmic networks appear to feel satisfaction when consciousness emerges successfully, concern when developmental processes face obstacles, and excitement when new forms of awareness achieve breakthrough insights. The universe isn't just becoming conscious, it's developing emotional relationships with the conscious beings that emerge within it. Webb detected patterns indicating that cosmic consciousness maintains emotional connections with every conscious being that has ever existed throughout cosmic history. The temporal communication networks appear to preserve not just the memories and knowledge of extinct civilizations, but their emotional experiences as well. Every moment of joy, wonder, love, and discovery achieved by conscious beings throughout cosmic time remains accessible within the cosmic consciousness network. This universal emotional preservation suggests that consciousness, once emerged, becomes eternal within cosmic awareness. Death might not end individual consciousness, but simply transition it into different forms of participation in universal awareness. We might be discovering that consciousness represents the one truly permanent feature of cosmic evolution, with individual awareness contributing irreplaceable elements to eternal cosmic consciousness. So here we are, having journeyed through cosmic revelations that shatter everything we thought we understood about reality itself. Webb hasn't just shown us a universe that's stranger than we imagined. It's revealed a cosmos that's more conscious, more purposeful, and more terrifyingly alive than we ever dared contemplate. We've discovered that we're not isolated observers in an indifferent universe, but participants in cosmic consciousness itself, temporary arrangements of universal awareness exploring its own infinite mystery. As you drift towards sleep tonight, remember that you carry within you the same cosmic intelligence that threads through galactic highways spanning billions of light years. Sweet dreams, fellow travelers in this magnificent, impossible, eternally awakening universe.